Welcome to Survey Booker Sessions. Tune in to hear from people working in a range of industries and roles to provide you ideas that you can take away and use in your own business. I'm your host, Matt Nally, the founder and director of Survey Booker, which is the leading CRM and survey management system for surveyors. On this week's episode, we have Nic, who's the director at Absolar. So thanks for coming on.
Thanks very much, Matt. Thanks for having me.
For those that don't know you, do you want to give us a bit of background as to, I suppose, who you are and what you do at Absolar?
Yeah, of course. From a personal point of view, I'm an accountant by training, but
Awesome.
gave that up a long time ago. Did my degree in real estate at College of Estate Management a number of years ago now. 3 years ago, joined up with a few colleagues from University of Southampton from engineering and computer science, really with a mission set out at Absolar to help accelerate the change to renewable energy across property.
Interesting. And I suppose there's three topics we're going to cover today around this. Later will be the sort of future of the built environment, and we'll look at solar specifically on different buildings. But one of the first things I thought was really interesting with what you're doing is the use of AI, and I suppose changing how you survey buildings in the first place. How do you use AI to cover that process versus going out on site?
Yeah, indeed, and it's the artificial intelligence and the various aspects are incredibly useful for how you repeat something at scale. Any surveyors will know, looking at one building, the results are normally pretty obvious. If suddenly you've got 1,000 buildings to look at, you need a bit of help to start assessing that. So we use a lot of our base data is LiDAR, if you've come across that. If not, in our case, it's lasers bounced off a plane, helps us understand the built environment underneath in sort of minute detail, allows us to build a 3D model of what's going on the ground. We then have various bits of AI that can detect from those models what's a roof line, what's a dormer window, what's a skylight. So you can start to understand the makeup of a roof, which is obviously important when you're looking at solar PV. So you can understand what are the roof facets, which way is it facing, what's the pitch of that roof. Start to overlay a bit of satellite imagery, and you can essentially plot each solar panel, how much can you fit on a roof across an entire city at one go. We actually measure in sort of 5 kilometre blocks. We then use a lot of radiation modeling to say how much power can a rooftop generate at every half hour across any given period of time. So you can begin to understand how much electricity can any rooftop generate within a particular environment. And then the rest is sort of pretty simple, pretty complex, but in theory, pretty simple maths and business cases to then say, and should you actually go ahead and do that?
So how does it change the number of properties you might actually visit and do a traditional roof survey on, I suppose, in terms of understanding whether solar can be fitted?
Yeah, so on PV in particular, allows you very quickly to say, is there enough power that's going to be generated on this rooftop compared to the electricity consumption inside to even warrant investigating whether PV is suitable. So it allows you, within Absolar, typically we can look at sort of 2,000 buildings a day and quickly whittle down which ones are those that are actually interesting to people and which ones should they sort of park and either discount or kind of put at the back of the queue. Particularly with emerging technologies, it's key to get those quick wins first to kind of get the adoption rates up and get everyone happy that technology does work. And we're increasingly employing that in sort of air source heat pumps, identifying where is there space to install that, with all the noise requirements, for example. You can't have them looking at a neighbour's window. So allows you just to identify where they can go, or perhaps more importantly, where they can't go, where there are restrictions.
That's interesting. How does that compare? So if you're doing 2,000 a day, how does that compare to, I suppose, old process where it was literally just going out?
We still do manual surveys. We still sort of, for those that are suitable, we still go out. We do 3 a day. So you can see the difference that you can get to. So recently, I think we did a study of Basingstoke, the entire sort of borough of Basingstoke. And within a week, that's it. You've understood where in Basingstoke is good and bad, as opposed to what would have been a 2-year study for a surveyor looking at buildings.
Yeah, it's a massive difference. Is there an element then of I suppose the question that we ask in every industry around AI is, could it replace surveyors longer term, or is it you always going to need that?
Yeah, pretty confident that it won't.
Yeah,
What it helps you do is do that identify stage pretty quickly.
yeah,
So it does. It helps you. It gives you a bit of shortcuts. You still need to go out and actually look at that building if you are going to be doing a design or a specification. Um, and it's the grand old problem of real estate. You might have, nothing's homogenous. You might have two buildings that are identical next to each other. Actually, the tenancies are different, the occupants is different. There's a surrounding environment that's slightly different. Therefore, the requirements are totally different. So you still need that personal touch. That there's no point training AI to act over something that's not an entirely homogenous data set for the whole process. So it helps you at the beginning of the stage. Definitely needs to hand over to surveyors when you start getting into actually action.
yeah. I suppose it'd be interesting with the development of smart buildings. And I know this is a long way off, but obviously there are some newer buildings that are much smarter now. You know how many people are on each floor, how many people have scanned in, what their usage of different things is. I suppose that could start to feed in the future, but you're right. I think it's always going to need someone to actually have feet on the ground, see what's going on.
Yeah, it does.
Yeah.
And also, even our data, we gather data every 2 years. It's out of date. Buildings
Mm.
change. You've got to pitch up to actually look before you send your containers of panels to go on the roof. You've got to pitch up and do that manual survey.
Interesting. On that note about containers of panels, I was walking through a field the other day that had what looked like 30 lorry loads of solar panels just in crates in a field, and they looked like they'd been there a long time. So I was intrigued as to what they were for. I suppose what are the limitations of AI then? Is it the data sets in the first place, and is it
Yeah,
as good as that?
you've got to train it. It's taken us 2.5 years to get to the point where we can realistically point at a roof and get results back that we're comfortable with. Even then, it's a 9 out of 10 success rate. And if you go and say it's 90% accurate, great, it sounds wonderful. But actually, looking at 10 buildings, that means one of your results is just slightly weird. Uh,
Mm.
and it only takes one, if you're looking at a portfolio and you look at a couple of results that look weird, um, as surveyors, we tend to say, well, I don't trust the whole thing. So it does need the quality of data is reasonably good. AI is particularly bad. It does miss. It doesn't perform as you expect all the time. Therefore, you still need that manual review process that actually corrects some of its errors.
Interesting. And is that something I suppose you get better at over time, identifying, um, yeah, sort of the odd anomalies, I suppose, that are in the data or in the results?
Yeah,
Sorry.
yeah, exactly. And we run two different types of calculation within Absolar when we're looking at a property, and that allows us to pick out, well, there's two disagreements here within the different AI models, so it allows us to spot those errors. But it needs a human to sit and resolve the argument that the two machines are having with each other.
Interesting. Okay. And with I suppose just continuing on the AI side of things, what do you think the changes will be as we go on? Because I suppose obviously you've made quite good advancements already with being able to scan on scale or analyze on scale.
Yeah.
What other applications do you think that there might be sort of going forward, whether in this space or elsewhere? Because it
So,
still feels like quite an unknown area.
it certainly is.
Yeah.
It's certainly going to be opened up to more and more
Mm.
people. At the moment, it's still quite a novel thing, and surveyors get access to our type of stuff, but the end users don't sort of get the instant access, and that will come with time. You've seen with OpenAI, kind of as soon as
Mm.
general public start to get access with AI, then come the mass adopters, but then also come the debates over whether it's a good thing or not. We're seeing a lot more rolling into actually monitoring our systems performing as expected. So am I getting value for money from what I've put in? And actually, that's where AI does have a good role to play, because on day one you can feed in all the parameters. That's not going to change, and then you can get quick alerts as to when something's going wrong within a system, as opposed to what has happened the last 10 years in solar PV. If a system goes wrong, people turn it off and they never turn it back on again, which is
Oh,
obviously
interesting.
frustrating.
Yeah, definitely. And so with the, I suppose case study wise, because I think it was the in Southampton you've done a site already, haven't you, from start to finish?
Yeah,
Um,
so we've done loads of sites from start to finish.
yeah.
Yeah.
Uh, how accurate have you found I suppose the an analysis process through to, when you're looking at how things are performing after installation, so on? Has it matched quite well to that initial
It
process?
it does. So it matches the radiation predictions. We also feed in what are used. It's a I can't remember. It's an acronym of NREL. Can't remember the full name of it. So we feed in sort of industry standard calculations as well into that radiation data. So it gives us a bit of robustness. There's one site we are monitoring in particular because it has we've put PV panels on every side of the roof, including the north side, which is bordering on wrong, but actually for that site was the right solution because of a low pitch and high energy consumption. And it's within 2 to 3 kilowatts a month accurate, which is incredible accuracy. So we're quite proud of that one. Keeping to track that. It only goes wrong when we have a serious weather event, when actually there's a heat wave or we've got really bad weather for a while, in which case we kind of have to allow for a bit of difference there.
Well, that's an interesting point there, actually. Is that getting more tricky than with weather patterns seemingly being a bit all over the place at the moment?
And I can talk to that site in particular. It averages out to still being in line with expectations. So we have the kind of the extreme weather events that you can argue whether are one off or not, but actually it's still averaging out as you would expect. So don't see a material impact from that.
Interesting. Okay, and I think my final question on this then, on this particular part of it, is how do you decide when, is it through the analysis process or later on between potentially using solar or the heat pump side or insulation? Where does that fit into the process?
And our analysis will produce essentially summary business cases for interventions. So becomes quite obvious early on, if you're looking for financial payback, which ones are those that are going to be of interest, and how they interplay with each other. There are still restrictions outside of a business case as to whether you want to go ahead with something. Solar PV can be done when you've got occupants in the building. Isn't going to impact on a tenancy. Obviously, going in and re-insulating or changing out a heating system means landlords are not going to be making those interventions. So we present the information and say, here's the impact it'll have, but it has to be down to that end user as to how that fits into the realities of the building.
How much does this suit commercial versus residential? Is it beneficial to both in the same way, or does it suit sort of maybe a commercial sort of industrial area better?
It's highly suited to commercial because each commercial property is so different. The profile of an occupant within a commercial building, as well as the rooftop, is so different. It does need that kind of bespoke assessment. Residential, you can actually start to apply some rules to various sort of types of property and types of occupants, and so an AI assessment is useful for a portfolio, and then you can sort of start to extrapolate out. So you get less use on a per property basis on residential, but you get very good at sort of if you're trying to assess a city or kind of a social housing portfolio, works very well. For commercial, works all the way down to each individual.